Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos.
Right, let's have a look at this 2018 question on integration. Parts of the graphs of the function h of x equal to x, which is a straight line, and k of x equal to x cubed, so it's a cubic, so it turns twice, are shown in the diagram below. Find the coordinates of the points of intersection of the graphs of the two functions. Okay, so the point of intersection of graphs you can find typically with simultaneous equations, but it probably wouldn't work here too well because we just have x and x cubed. So what we were asking is, where is the function? Well, let me go back one step. Where is h of x equal to k of x? Okay, in maths language, that's what that English line means. Okay, so of course h of x is x. We're asking where is x equal to x cubed? Okay, let's bring all over to one side. And I'm going to bring everything over to the right. So x cubed minus x equal to 0. So I just brought him over here. Okay, and let it equal to 0, or 0 equals x cubed minus x. Okay, and I'd like to solve this. So the easiest way to solve this is to factor out the x that they have in common, like we would have done in junior cert, so taking out the highest common factor, which is an x. Okay, and then solve it. So let each factors equal 0. So x equals 0 is one solution, and then let the other factor equal 0. Let's solve this one. X squared is equal to 1, and x is equal to the square root of 1, which is in fact plus or minus 1. Okay, always know that when you square a minus or a plus number, you will get a plus answer. Okay, so when you have x squared equal to a plus answer, the original number could have been plus or minus. Okay, so let's find our y coordinates of them. So h of x, which is y, is equal to x. Okay, I could use either one. I'm just picking the easier function, which is the x function. So when x is equal to 0, y is equal to 0. When x is equal to 1, y is equal to 1. And when x is equal to minus 1, y was equal to minus 1. Okay, because in functions, this is your h of x axis, or your k of x axis, or your y axis. So y is always your function. So y is equal to x in this one. So to write down coordinates then, I have 0, 0, I have 1 and 1, and I have minus 1, minus 1. So they are the points of intersection of the graphs: minus 1, 0, 0, and 1, 1. B part 1. Find the total area enclosed between the graphs of the two functions. Okay, and this is where integration comes out on its own, where you have to find the area between two curves. And to do that, it is always the integral of the top minus the bottom curve. Okay, that's how you get the area. Okay, so let me write that down. So when we're doing it, it's always the integral of the top curve minus the bottom curve. Okay, so when we get the area, when you get the integral of the top curve, what you do is you get the area of all of this. So between the x-axis and that curve, right up. Okay, then when you get the integral of the bottom curve, you get between the bottom curve and the x-axis. And when you subtract them, of course, you get the bit in the middle, the area between the curves. Okay, so that's why it's always the top minus the bottom, and it's with respect to the x-axis. And of course, you need some sort of a stopping point as well to know where do you stop summing up or integrating that area, because what it does is it integrates this area the whole way up, so you need some sort of a stop point. Okay, so top curve minus the bottom curve. So my top curve is x, and my bottom curve is the x cubed one. Okay, where am I integrating between? Well, remember I said it's between the x-axis, so you're going to do between 0 and 1, okay, because that point there is 1. Okay, and then we'll multiply our answer by 2 because these are fully symmetrical. So the area down here is the same as the area up here, and that is the best way to do it. So I am going to integrate between 0 and 1, x minus x cubed dx. Okay, so let's do that. So top curve minus the bottom curve. Okay, and of course I'm going to multiply it by 2. I'll just stick that there so that I don't forget it. So let's integrate. So we'll have x squared over 2. So up a power in x divide by your new power, up a power in x divide by the new power. Okay, and that's between 0 and 1. So let's sub in the top minus the bottom. So it's 1 squared, which is 1 over 2 minus 1 over 4. So that's the top minus the bottom. So 1 squared is 1, so that's a half minus a quarter minus 0, so that's a quarter. Okay, let's multiply it by 2. So it's a half units squared. That's what I get for the area between the graphs of the two functions. Okay, this was a quarter units squared. And of course, this is a quarter units squared. Okay, part 2. On the diagram on the previous page, using symmetry or otherwise, draw the graph of k minus 1, the inverse function of k. So k was x cubed. So the inverse function, let me clean up my graph. Okay. So the easiest way to do it is by symmetry, okay? So it'll go like that. And then you try and have them crossing at exactly the same points. Okay, so make sure you label your graph. What did they call that? K to the minus 1. Okay, or something to that effect. So that was that question. So the biggie in that one was working out the points of intersection, which is a typical question that comes first when you get the area under the curve, so that you know, I suppose, the gates that you're integrating between, so 0 and 1. Then top curve minus the bottom curve to give you the area, and then, of course, the inverse function. So 10 marks for finding the points of intersection, 10 marks for the area under the curve, 5 marks for the inverse function.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.